So I welcome all the panelists for our next session, which is Mr. Parveen Nanda from Greenko, Mr. Panda from NTPC, and Mr. Arul from Ayana Power. Welcome to all of you. And Mr. Furkoff from S&P Global Platts is going to be co-moderating this session with me. So I'll just take a quick minute to introduce all our panelists, and then we move on to the discussion. So this session is on perspective and plans of renewable energy developers. We have with us Mr. PM Nanda, who is Senior Vice President, Greenko Group. He has more than 33 years of experience in the energy sector, including specialized hydropower experience of 28 years and more than 5 years in the hybrid renewable energy sector. He's currently working on pump storage projects and 2 renewable integrated projects with storage. He has worked on more than 20 hydro projects and an equal number of solar and wind projects from concept to commissioning spread across 15 states and country. With challenging Himalayan and climatically varied conditions and constrained timelines. He also has experience in complete project management, including planning, execution, techno-commercial issues, environmental and social issues of hydro and renewable power projects. He's worked with both government and private sectors. Very welcome to you, sir. Then we have with us Mr. Panda, who is General Manager, Hydrogen NTPC. He has 3 decades of experience working at NTPC, currently responsible for hydrogen mobility, hydrogen-based micro CHP, hydrogen-based microgrid system, and hydrogen-based pilot plant for chemicals like green methanol and green ammonia. He's been involved with operation of gas-based power stations to being internal training manager and trainer at NTPC. He's also served as OSD to CMD office at NTPC and has worked extensively in training and quality management area. He's a mechanical engineer and has an MTech in power generation technology, a 6 Sigma black belt holder, and a certified instructional design trainer. Very warm welcome to you, Mr. Panda. Then we have Dr. Arul Shanmugasundaram, who is Director Operations at Ayana Power. In his current role, he is responsible for the BD, engineering, technology, IT, and asset management functions. In his earlier stint of 7 years at Tata Power, he held various roles in technology, EPC, BD, EPC, and manufacturing as CEO. He also has been involved in the commissioning of more than 2.5 gigawatt peak of utility scale projects and several hundred megawatt of rooftop projects. He was also an applied materials. He was at Applied Materials in the United States for 15 years, where he worked on semiconductor equipment and process development. He has a BTech degree from IIT Madras and a master's degree and PhD from Cornell. So very esteemed panel there, and I welcome all the panelists. And we're now ready to move on to our discussion part. We have with us Mr. Furkoff, who will be co-moderating the panel with me. So the format can be that we can have 5 to 7 minutes of remarks from each of our panelists, and then we can have a round of questions with Mr. Furkoff and then with me. So if we can move to Mr. Nanda first for your remarks, sir.
Yeah, good morning, everybody. Good afternoon now.
So your volume is a little low. If you can speak a little louder, sir, please.
Is it audible now?
Still a little low, sir.
Full volume now.
All right, sir. Yeah, we can hear you. It's better now.
Yeah. Okay. I'll be a little bit closer to it now.
Yeah.
Yeah. Good afternoon, everybody. Yeah, I am PM Nanda. I am working in Greenko Group in India, which is among the largest renewable energy producers in India. As regards this, we are presently have around 7.2 gigawatt of renewable energy generation as of now, and we are now entering in a big way in the pump storage projects. So already one of the pump storage projects is under execution, which is a 1200 megawatt project with 9 hours of storage. And we have in the pipeline another 5 projects. Out of that, 3 are in the advanced stage of clearances. They are again ranging from 1260 megawatt to 2500 megawatt. So the plan is that we are planning to complete all these projects by 2025. So that's the plan we are going ahead with this project. Why I am telling out this pump storage projects is because our hydrogen plan is also linked to the creation of large pump storage projects in that matter. As far as plans and policies come, like all other renewable energy vendors, developers, we are also very keen to join into this hydrogen foray, because ultimately goal of decarbonization we can only achieve through the green hydrogen itself only. And what we are planning in our is, we are looking, as of now, we are looking at all sectors where we can use this green hydrogen concept, whether it is transportation, whether it is refineries, whether it is chemical industry or iron and steel industry. But how do we formulate that plan is somewhat suspect at this stage, because we don't have complete policies or monetization or the marketability of the green hydrogen in place as of now in the country. The availability of electrolyzers, size of electrolyzers are the issues which are plaguing the entire green hydrogen mission at this stage. Hopefully, another 3-4 years, by say 2025, we are expecting that most of the things will be in place, and that may enable us going full throttle on this hydrogen production at that stage. Linked to that, we personally feel that the major issue is regarding transportation of the green hydrogen. Why? Because there are two issues. As per the schematic plan, if we look at, everybody intends to use the excess availability of the solar power in the system during the peak time to avoid curtailments and to use that low cost power for the green hydrogen part. So if we look at that part, then the grid becomes very important part. And does our grid has that flexibility to take care of that additional load which is available and which is not being consumed at that point of time, to carry to the respective locations where we can have green hydrogen generation. So I think grid is going to play a very important role in the beginning, till this entire transportation system of the hydrogen develops, whether it is pipelines or whether it is other sources of mode of transportation, or it is storage of high caverns in big caverns or big locations like that. So as of now, I think to expedite the matter, the grid will have an important role to play in this green hydrogen segment. On our part, we are in touch with the industries directly. We are in touch with DISCOMs to formulate the future plans for the green hydrogen that matter. So as of now, it's all on the paper stage and the planning stage, but the marketability part is being evaluated on a bigger context to see that what can we do, say around 2025 or 2026. That's what we are looking at this juncture in our plans. So as we go ahead, there are certain interventions which are required from the government side on this matter. Is first part is on the, because it might need transportation through grid to the far-flung locations or the respective locations of the output where we need to use this green hydrogen. So ISTS waivers, etc., and grid mechanisms which may make this green hydrogen as a cost-effective measure to be used at all locations in all modes of usage. So that's one thing which I think is an issue which needs to be looked into by Government of India. And there are other common issues which I think must have been raised by the other panelists also in other discussions also, like GST waivers, reduction in duties, special status to the green hydrogen projects, creating a single window clearance for green hydrogen projects. So all those things are, I think, mandatorily required to make atmosphere conducive for developers to venture into this. As of now, situation is very optimistic, but the ground conditions are not very encouraging. So till we make these conditions encouraging by these facilitative measures and regulatory provisions on waivers, GSTs, duties, etc., I think this green hydrogen mission accomplishment will be a big challenge. So that's what our feeling in this case is. So we have big plans. We are going through with those plans because in our mission also as Greenko also, so decarbonization is our biggest mission. And till we join into this green hydro mission, we cannot achieve that goal of decarbonization for our company as well. So from my side, I feel that certain enabling measures and the marketability, I think that is where things need to improve in coming years so that we can achieve. But from our side, this our pump storage projects is part of this mission on which we have already started work. Thank you. Thank you, everybody.
Thank you, Mr. Nanda. We can now move to Mr. Panda from NTPC for his brief remarks.
Hi, good afternoon. And I'm so sorry that I am from a moving vehicle I am speaking, but there are certain things you cannot avoid.
Yes, sir.
Now, so with that apology and with greetings to the moderator and all my panelists and listeners, I'll start. Now, let us try to understand why we are doing this. And speaking from NTPC, we derive our inspiration from our Honorable Prime Minister, Honorable Power Minister, and I'll summarize all this from three angles. Number one, we want to have self-reliance. In India, we all of us know acutely that we import a lot of petroleum products for driving our car, buses, trucks, everything, including trains. Then there is an issue of decarbonization. And after that, can I make my life simpler? Number one, since I am importing a lot of petroleum products, what I can do about that? Now, I feel India is very fortunate to have abundance of solar energy, a long coastline where we can have offshore wind thing, and then within the landmass, we can have a lot of wind projects. Sum total, I am very rich in renewable energy. And if I can quote our Honorable Power Minister, he says, what is under the ground, let it be there. If coal is there, let coal be there. If petroleum products are there, let it be there. We aim to derive energy from what is above the ground, which means either the wind or solar. If I have this, then what I do next? NTPC has a plan to add 60 gigawatt capacity, a lot of power, in another 10 years time. So talking about the number, I'll give some perspective. In NTPC, whatever capacity we have added in last 45 years, we are trying to replicate the same with renewable energy in next 10 years time. Once I have that power, so I'll try to enter into every segment where there is a possibility to use hydrogen, green hydrogen, and thereby achieving the targets, thereby achieving the intentions of our Honorable Prime Minister and Honorable Power Minister. What does it mean? We want to be into green mobility, where we'll start running the buses. I try to enter into blending of natural gas for our CGD networks. I'll try to have green chemicals, including green methanol, green ammonia. I would like to have my presence felt in the energy storage. And when I talk about energy storage, it would be microgrid. It is about replacing the current DG sets as a backup power source. Right now, today we're speaking in 2021, and we have decided to enter into this in this year. Like my previous speaker observed, there are a lot of difficulties, and I assume in every field of business there would always be challenges. There would be always bottlenecks, and sometimes you get a feeling that nothing is possible more. But then we do find a way out, and ultimately whatever we are trying to do through hydrogen, it is not a fanciful idea. It is the requirement. It is something which is not negotiable. It is something which we ought to have done long back. Fair enough, but we'll do this right now and we'll achieve the target. So we'll talk about the other plans in detail later on, but as of now, this is what NTPC's stand is. Thank you.
Thank you, sir. Now we can move to Mr. Arul from Ayana Power for his brief remarks, and then we can move on to our questions.
Hi, thanks. See, I think I wanted to just briefly touch on hydrogen. Of course, the driver for hydrogen, as everyone has said, is decarbonization, and obviously there are multiple use cases for hydrogen. Of course, one is the replacement of fossil fuels, or mixing with the natural gas at a certain 10-20% level, which appears to be the easiest use case to be implemented. Then you have the use case for fuel cell vehicles. And of course, there's a third use case for E to E, that's electricity to electricity. So you can convert the energy back to energy, right? Of course, that's probably the most least efficient and the more expensive use case. And we see that in the early days, right, we believe the fossil fuel replacement or add-on or partial replacement of fossil fuels, or in refineries or in fertilizer manufacturing, or other places where it's hydrogen is used. That's one use case where we see there'll be traction. The second use case is mixing with natural gas for replacement of fossil fuels. These two use cases we see as immediate. The fuel cell use case, while we believe will be predominant, but currently the market is not there for that. Right, and so this is the drivers for hydrogen, and one of the challenges is transportation. So currently, as the first speaker mentioned, right, we were looking at hydrogen primarily from the perspective of we have a lot of excess power in our solar plants. The grid evacuation is limited, so we wanted to see how do I harness this excess power that I'm not able to evacuate, and that is the driver for us to look at hydrogen, because it's a wasted power. If I can convert it into something useful, then I can get a value proposition for that wasted power, and also begin the journey in hydrogen. I think that is our initial driver for looking at hydrogen, and we are and the 2 or 3 challenges are that currently the capital expenditure for electrolyzers, it's quite high. So now how do I justify using the electrolyzer for a 6-hour window vis-a-vis an 18 or 20-hour window? I think that makes a big difference in terms of the cost. So I think to that extent, I think Greenko's efforts on pumped hydro and getting closer to 18-20 hours of power, I think that would be helpful. Of course, one has to weigh the additional cost of power vis-a-vis the cost of electrolyzer, the capex, amortized capex of electrolyzer based on production, vis-a-vis the increased cost of power to provide a longer duration green power. So when we are talking about green hydrogen, we are restricted to using green power only, and I don't believe there is any banking per se allowed. So in that context, I can't run the facility 24 hours by definition today. Right, I'm limited to 6 or 8 hours, and I think that's the solution. I think the industry has to think through what is the best way to optimize, compare reducing power cost or improving the utilization of the electrolyzer. I think that's a choice that needs to be made near term. So on near term, as I said, our focus is really looking at either an ammonia application, because that's the only one we can transport, because our sites are remote. where we have these excess power and there's not much of an industry cluster around. Ideally, you will have an industry cluster around and the power plant right next door, and I think you can easily supply the hydrogen, generate the hydrogen locally and supply it or pipe it in short distances. But currently, that's not where our solar plants are. Where our solar plants are is where the industry is requiring hydrogen is quite far. So, so we are naturally constrained to focus on ammonia as the production at the site and transporting ammonia to the various locations for consumption. I think this is probably the simplest thing to do in the current context of where our renewable plant is. But if we were to start it from scratch and look at a hydrogen economy, then we'll be looking at setting up a plant around an industrial cluster where there is a need for hydrogen usage and we can pipe it at a very short distance. I think that would be the ideal context. So I think this is overall the context I wanted to give on hydrogen. One is, yes, there are a couple of use cases, ammonia being the first one, and maybe mixing with natural gas pipelines at 20%. Those two use cases could be triggered immediately. The fuel cell, the electrolyzer plus fuel cell use case, the challenge with that case is the conversion, the net conversion energy efficiency is around 35 to 40%. So your cost, plus you have the additional capex of electrolyzer plus fuel cell. So if you're competing with a diesel or something, I think it's still possible and viable. But where there is no diesel per se, if you're competing with the electricity, I think that's a difficult use case to justify. So I think where the diesel is difficult to reach, diesel is the only source. I think there this case can still be considered. Of course, that's a simpler case also from that perspective, and you can get to 24/7 electricity, almost the equivalent of diesel generated power. I think that use case is there. I think currently we're not finding many instances for that use case, but certainly that is another option that is still available.
Thank you so much. Thank you so much, Mr. Arul. So now we can move to Mr. Furkoff, who has a list of questions for our panelists. And after his questions, I will take my questions as well as the delegate questions. Mr. Furkoff, on to you for your questions.
Thank you. Yes, I thank you very much for the introduction on the situation in India at the moment. Yeah, I tend to imagine that in India for the coming 10, 20 years, you will see an enormous amount of extra demand coming into the market for electricity year after year, a lot of new usage. Would there be enough space to focus on hydrogen as well with surplus electricity? Yeah, maybe I can ask all three gentlemen. I think everybody is involved very much in electricity.
See, if I can start with that. See, the challenge is we need to decarbonize, right? We have a fair amount of fossil fuel usage, and if we are going to get to net zero, I think replacement of fossil fuels, especially in the metals industry, whether it's a steel or aluminum or copper, right? There, I think there's a fair amount of fossil fuels used, and if you are going to go to a green steel, I think hydrogen appears to be the least resistance path for that net zero conversion. To that degree, I think we have. I know although India is not yet signed up for the net zero, we believe that this transition would be required, right? So, and we do, as someone said, that we are blessed with abundant natural resources in terms of solar energy, right? And we have wind also. So I think we do see a need to do this, not driven by cost, but driven by the need for decarbonization.
Thank you.
Yeah, there's another point which needs to be added. This is, as the energy market in India, what we are seeing is there is a gap between the peak demand and the lean demand is increasing with every coming year.
Yeah.
So now our need is to cater to our peak demand. So there will be a lot of surplus energy available during the lean period in the market. Now that's the area where we need to capitalize. That's why I was mentioning in my initial brief also that the grid is going to play a very big role, or the storage mechanism of either hydrogen or energy is going to play a huge role in that area. So the difference of this peak demand and lean demand gap, which is huge, which is almost 50 gigawatt as of now and likely to increase further as we go on producing more solar and wind, I think is the most encouraging point for us to expedite our hydrogen mission, because that will give us the cheapest energy for conversion for the various consumptive uses of the hydrogen.
No, thank you very much.
Mr.
Yeah, I
Nanda,
was wondering.
to you
Sorry.
now. I was just saying that we can move to Mr. Nanda now for the same question. Mr. Nanda, the same question for you, please.
I have already answered. I've already answered.
Sorry,
Panda is the answer.
so sorry, Mr. Panda, the question for you.
Yeah. No, so I'll like to put this in a slightly different way. Now, new options should always come. Like say 2 years back, nobody was talking about battery storage. 1.5 years back, till the COVID thing happened, nobody was talking about hydrogen. Now everybody is talking about all this. The point is, we'll always have newer options coming into the market, and no electricity market. It is not a question of India or USA. No in the market always it would be a favorable thing to play. But I need to find out what is makes country for people, common man, and for overall climate. Now, if I consider all this, then my priorities are decided. Then actually, I do not have any option left. So where does that leave us? That leaves us with solar power, wind power, and I want to optimize or amortize the capex on electrolyzers. Then I go for battery storage. That's it. Additionally, one more thing I will add. NTPC has decided to play a significant role in Ladakh, particularly to make electricity available in the remotest part of Ladakh where the grid may not reach in 5 years' time. In that condition, I'll have to depend on the solar power in combination with battery storage or other things. Like one of the speakers was mentioning that a grid is going to play a role. So my point would be the grid or off grid. The point is that how I can reach the energy, reach the common man in either of these ways, and then then I have to take the hydrogen route. That's it. Thank you.
Thank you.
So take this Ladakh case itself. See, the potential available in Ladakh is huge. So, and the consumption requirement in the Ladakh is not going to be that much. So even in that case, whatever we do in Ladakh will need to be transported in one way or the other to the other parts of India. So eventually, for Ladakh to make self-dependent, we'll have excess availability, which again will need a transportation mechanism to the other parts of the country.
I'll, sir, put this in a slightly different way. Now, when we say Ladakh demand is less, how do I judge that? By the electricity demand, frequency, grid-connected power supply sources. What about those schools in the remotest part of Ladakh, which remains under shutdown for more than 5 months? Now, because I have never supplied power to those parts, so I do not know what is the demand. what is about those residential clusters where even that when the temperature goes to minus 25 degrees centigrade and they do not have power, leave aside round the clock electricity, they do not have power. So they depend on the firewood, they depend on kerosene, and just see that kerosene or that diesel, every liter of kerosene or diesel that I use at Ladakh has to go from either the Mathura refinery or in the plains. What's about that cost? So the point is, if I want all my citizens, those who are staying in Ladakh, I am no better than my Ladakh counterpart, that I should have around the clock electricity at all season. So what about my other counterpart, the other citizens of Ladakh? Why they should be deprived of the electricity or any energy? There comes the role. So that is why I said grid or grid, both should be there. And then my primary focus is how I can make that energy reach in those locations, which otherwise would not have been possible. Maybe because I am coming from NTPC background, it is easy for me to look at the things that way. But that is what NTPC's standpoint.
Thank you very
You're
much.
right, sir. We fully agree. Because the decision pattern in Ladakh, in the summer season and winter season, the variation level is very huge. The requirement pattern is just so. That's why this is an issue which needs to be addressed.
There would be issues always. Say in Delhi, peak summer is above 7,000 megawatt. In other period of time, say in early November, it is half of that. There would always be challenges, and that is why engineers are for. Yesterday we observed Engineers Day, and that is the role, that's the duty, that's the obligation of engineering as a profession to make this feasible. That's it.
Thank you very much. Yeah, I think at the moment with hydrogen and transforming part of the economy to hydrogen, people sometimes bring up that it's sort of a chicken and egg problem. You need to have the demand to be able to sell your hydrogen. And sometimes people are waiting at the sidelines because there's not hydrogen yet. You think the government in this field, could push a little bit more in several areas to create more demand, perhaps for hydrogen, or make maybe production more feasible at the moment?
See, currently the government, through the National Hydrogen Mission, what they are trying to do is to mandate. See, today hydrogen is used. It's only how it's generated is different. It's a brown, black, blue, gray, whatever. It's not blue, obviously. It's brown or gray or black, right? So currently, what the government is saying is wherever such hydrogen is used, these industries shall be mandated to do a certain percentage of them from clean hydrogen. I think that's how the government is trying to bring the demand into the marketplace. Certainly, the quantum or magnitude is still less. It's like RPO obligation where you can slowly increase the percentage of the hydrogen you would use over a period of time so that the costs are controlled, right? Because I think early investments in electrolyzer also, it's fairly capex intensive. The OPEX costs are not the cost driver. So currently where the costs are high, if you mandate 100%, that may not be efficient. So I think similar to the RPO, I think a similar green hydrogen obligation is what the government is planning to integrate to build the capacity up so that when the costs are achieved at a lower scale, I think your on the capacity also can increase. I think that's how they are structuring this. I think they've announced the mission. I think we have, of course, they also have some tenders they are planning. I think that would be interesting to see when they come for generation of 5 gigawatt of electrolyzers. I think that's also in the plans.
First step in this direction already in place, as Arul also said, with these RPO obligations coming in the policy. I think that's a first step to create the demand in the market. And secondly, what we see is because we have had a lot of discussions with the industries directly. while formulating our plans for the future. I think industries are also very forthcoming in this case to create a space for the hydrogen in their industry for their decarbonization part and their fulfillment of international requirements. I think coming very shortly, we'll say a lot of demand emerging in the market in this area.
Thank you very much.
I would say, I would say the government is doing its bit. Yesterday, we got the news that the PLI scheme has been made applicable for hydrogen vehicles also. One. Second, the government is bringing out an enabling policy for use of green hydrogen for making green ammonia and in various fields. One thing it will be helpful to remember and appreciate always that a government is not like a god that it knows everything. There is an equal responsibility of the industry who looks at things and apprise the relevant bodies in the government so that what is required to be done is done. You know, I'll just draw a parallel. Say, let us go back to 200 years back. People were using horse carriages, and which are of course much cheaper in comparison to a car. But then there is an inherent value in the car. The government invested on the highways. The government invested on the supply chain for the petrol and diesel, and that is how the current state of internal combustion engines are there. Similarly, for hydrogen, government is asking for feedback. All industries, I know all of us here are providing input to the government in various ways, and then things would start moving. And I'll tell you, because NTPC is a public sector company, we are somewhat closer to the policy making bodies, and actually government is more bothered, more concerned on these issues than any of us. So that's how it is.
Thank you very much. Khushbu, would you have some additional questions?
Yes, I do. Thank you, Mr. Furkoff. My first question to all our panelists, maybe we can start with Mr. Arul first and then go on to next. That what are the technologies that you are, primarily looking at in the space of renewable energy for green hydrogen production?
See, I think your choices are fairly limited, right? You have solar, wind, and if you add anything else beyond those two, you are going to have a limitation in terms of what the cost, because the cost will increase, and you need about 60 units of electricity to make 1 kg of hydrogen. So if I increase that by 1 rupee, that's a 60 rupees increase, right? And that would sort of offset the utilization case. I think that's a balance one. Everyone has to assess the balance, and it's largely depends on the electrolyzer cost roadmaps. At the current electrolyzer cost roadmaps, you could justify maybe an integration with a pumped hydro, right? But I think going forward, if the electrolyzer costs are falling, I think that may not be justifiable. It may be better to just rely on a solar, wind, and operate it at a lower utilization or a lower PR. Talking about electrolyzer technologies themselves, obviously you have the alkaline-based electrolyzers, which are obviously in the marketplace for a long time. So they are well-proven, robust, mature technologies. You have the PEM-based electrolyzers that are emerging or that are reasonably there, and you also have the SCOE. Not much, but at least there are 1 or 2 players in that space also. So when you're talking about renewable power, you are not going to have firm power, you're going to have variable power. So, and also not for 24 hours. So to that extent, it appears that PEM seems to be better placed to integrate with renewable vis-a-vis the traditional alkaline electrolyzers, like I think. But it's still early days, I would say, in the electrolyzer development. So of course, hopefully there'll be some more innovation, because there are 2 things you have to worry about. One is the utilization 6 to 8 hours a day, which means you have to start stop completely. And second is the variability in the power itself. You're going to have a fair amount of fluctuations even during that 6 to 8 hours, and your electrolyzers have to be able to adapt to these fluctuations. So to that degree, I think PM seems to be better placed than others. Right? But I think we'll have to see how it evolves. I think it's early still. I think it's
Right. And a follow-up question to you on that note. So we had a baseline presentation from KPMG in the morning where they mentioned that, by 2030, they expect about 11 to 12 million tons of hydrogen demand in total, out of which they expect about 4 to 5 million tons of green hydrogen. Do you sort of agree with these demand numbers, and what would you feel are going to be the key sectors, the end use sectors that will drive this demand?
See, I think like I mentioned earlier, see my views, the metal industry, fertilizer production probably early, green ammonia, but I think the replacement of fossil fuels in steel and copper and aluminum manufacturing. I think that's probably the biggest, because I think that's happening in some other parts of the world. The green steel is branded and also gets a premium. I think there are people who are branding green steel, right? So I think that would be the early adopters. I'm not able to assess the demand numbers because I've not done a study on the industry and the consumption, but I also believe that fuel cell based, hydrogen fuel cell based trucks, right? I believe that will also happen. I think next to electric cars in transportation, I think this is be a one big use case. The steel, the fossil fuel replacement in the metal industry. I think these will be the two use cases I see that have a genuine demand and a drive, right? So I think that those two should happen. And the lower hanging fruit is the fertilizers and refineries.
Thank you. And Mr. Nanda, my question for you is slightly different. That Greenko is coming up with this very large integrated renewable energy project with pump storage. So are you also planning to use that pump storage in green hydrogen production to some extent whenever the project is ready?
Yeah, definitely. That's what our line of action is. We'll be pump storage projects will be a key component in our plan for the green hydrogen.
Right.
So that's why we have a continuous mega plan for that for coming 4 or 5 years. So by that time, we think that enabling issues will be in place. So we'll be ready with our pump storage plans by that time.
And a follow-up question to that would be that what sort of like, are there going to be a significant cost benefit in using this pump storage plant for green hydrogen production? And obviously, it will help in addressing intermittency issues to a very significant extent. But can you give us an estimate about the sort of benefits and costs that you foresee?
Benefit of the cost, it's an indirect benefit in the cost. See, once we deal with the intermittency of the solar and wind part, and we try to make it firm, the marketability of this green hydrogen becomes much more useful. So, like if we are going directly to the industry, the replacement they are doing for their DG sets and other things by replacing green hydrogen, so that is more cost effective to them from that point of view. So we feel that that's an area where in the initial phase, this is going to play a key role. The cost effectiveness is more likely to be ensured through those means. So that's why this is what we feel at this stage.
All right. My next question is for Mr. Panda. Mr. Panda, in NTPC, are you also focusing on carbon capture and CCUS technologies for green hydrogen production?
Yes.
Mr. Panda, we can't hear you properly. I think there's some disturbance on your end.
Okay, is it better?
Yeah, it's better. Maybe if you could
Hello?
switch. Yeah,
Yeah.
yeah. Maybe you could switch off your video. Due to video, there are bandwidth issues at times.
Yeah, is it better?
Yeah, it's definitely much better.
Thank you. So now we are focusing on CCU, not CCUS.
Okay.
So we are not storing, but you are utilizing. How? So we are putting up two pilot 10 tons per day green methanol plants. And for it, we are extracting carbon dioxide from the flue gases of power plants, mixing that with green hydrogen, making it react in a reactor, and making green methanol. So this is my answer to your question. So we are not going for CCUS, but CCU, carbon capture and utilizing that for making methanol. So
all right, and is there? This is just for our knowledge, since somebody asked in the first session, that is there any policy support for or incentive for CCU at the moment in our country?
right now there is none.
Okay.
But I'll put it in a different way. Right now, 90% of the methanol we are importing from outside. And why we are importing? Because that way it is cheaper. Supposing all countries or few countries who are making brown methanol, so to say, out of natural gas, they stop using that. So then automatically the price will go up. So in a way, whatever we are producing, that will be self-sufficient. So then that gap reduces much.
All right.
And as the scale goes up, then it will be cheaper. That has happened with everything, whether it is COVID vaccine or cars or electric scooters. The scale is going to help us.
Right.
We look at it that way.
And so in your previous question, you spoke about a PLI scheme which is coming up in the hydrogen space as well. Can you
yes
highlight some features in that scheme?
No, of course. So I must admit that I am not the right person to say that. But today newspaper we read that the government has made it open.
All right. Okay.
For hydrogen vehicles. So that is what I quoted. But yes, more things are coming for better.
All right, sir. My next question is to Mr. Arul. Mr. Arul, there was a recent news update regarding Ayana and Greenstart's partnership on hydrogen. Can you tell us some specifics of that partnership and what it is about, and what Ayana is planning in the next 2-3 years in this space?
See, I think green hydrogen is relatively new to this country. There are not many experts in this space in India, right? And so what we have looked to get support from Greenstart is in the implementation. Because see, while we are talking generically about technology, there's a fair amount of regulatory requirements as well as safety requirements associated with this. It's not a trivial thing like a solar, I could go set it up, right? You need experts in this area who have done it and who can support us in this journey. So that's the reason we have tied up with Greenstart, given their experience in Norway in this space. They have bring a wealth of experience and can help us do in terms of the overall partnership that has a lot of potential to evolve, right? I can't. Of course, initially we are starting with the technology support and feasibility studies, but yes, they could be an investor, they could be a partner, execution partner. There are multiple they could play on how we could partner with. I think that's something will evolve as we define our projects going forward. But initially, we are looking at a pilot, small pilot, primarily with the idea of using our excess clipped power that's lost, and also learning to the hydrogen space that's starting.
All right.
Get on that immediately.
All right. And I know we've already closed our session time, but there are so many questions from the delegates. So if our panelists permit me, I would like to take some of those questions. And if you can just stay for another 5 to 7 minutes with us, I hope.
Sure.
All right. The next question again to you, Mr. Arul, is that what are your expectations from the upcoming roadmap?
See, I know. I think I don't. I'm not really thought through it. I think we are only right now struggling to how to do it, how to do a pilot. What are the challenges? But I think one thing that is emerging from my standpoint is the whole regulatory landscape. It is not well defined. For example, if I want to go and set this up in a solar park, I don't know if the rules are defined. Whether it's in Karnataka or AP where we are looking at these two options. We have to work closely with the renewable energy development agencies and make sure there's a clear roadmap defined that for the regulatory aspects of it and approvals, so that there is a clarity. I think that is something which is not much talked about, but probably the number one thing, given the safety hazards associated with it. I think that should be the number one priority in developing a framework. I've not seen much of that, but I hope that will be prioritized.
All right. And Mr. Nanda, similar question for you. What are your expectations from this upcoming roadmap? And do you think the challenges that are already hampering the renewable energy sector in India in terms of discom payment issues or transmission or land acquisition, and all of these, do you expect this to sort of overshadow the expected green hydrogen development in the country?
Khushbu, there are two segments to which you have asked now. See, one is policy framework where we are very optimistic, definitely, because we have had a lot of discussions with the top government last few years or so on these frameworks, and they have been all very receptive, and the policies or the initiatives coming from we are optimistic, and the things are going in the right direction from that point of view. Second aspect is you have raised this regarding development of the project which is associated with the land acquisition or other issues. I think these issues were there and will be there, always remaining there. But the initiative has started, at least from the government side. If I get a pump storage project for that matter, we have bigger issues, all these issues in those projects. But the government has now set up committees which are looking into the issues of development, compressing the gestation period of the projects. So I think a thought process is on, and I don't think that we should not be optimistic. We are optimistic, expecting a lot to happen in coming.
All right. And since you spoke about pump storage, there was a question from someone in the delegates who wanted to know that what is your view, why are pump storage plants so underutilized in the country? And he also wanted to know what is the cost per unit for pump storage plants.
See, the cost per unit from the pump storage plant is a very wide term. See, if you are putting a plant of 100 megawatt, the cost is different. If you're putting a plant of 3000 megawatt, the cost is drastically different. And there's another segment to it. If you're putting a plant for 4 hours of storage, you have a different things on that matter. And if you're putting for 10 hours, it's a different. So it's very difficult to classify uniformly the cost coming out from the pump storage plant, what range it will go. But whatever plants we are putting up, we are seeing that it's very cost competitive at this stage of the time. What happens later on after 5 years, 10 years, when the batteries of mega scale are available or other technology of storage come up by that time. But still, going by the technical experience and reliability and durability and other things which concern with the life of the project as well, I think pump storage is going to be in the stay there whenever we consider for a long duration storage technologies.
Right. Mr. Panda, a similar question for you, sir, that what are your expectations from the upcoming roadmap, and what suggestions or what enablers you feel are important for green hydrogen development in the country at the moment? I think he has having some connection issues. So till the time we get him back, I have a question from the delegates. Maybe Mr. Arul can take this up. In terms of the grid improvements, what are the specific changes needed to it, and which policy reform measure is addressing this?
Yeah, I'm talking about in the context of hydrogen. I'm not sure there is a need for grid per se, right? So
I think they're asking more in a general sense, since you are a renewable energy development company.
see the grid. See, one of the challenges today, grid is from hydrogen perspective. What is required is we have to bypass all the state charges and be able to deliver power directly from a CTU to the hydrogen manufacturing, right? I think that would be the most efficient because we have to pay CSS and all these other charges. But in terms of grid improvements, there is a fair amount of work that's been undertaken by PGCIL, right? In terms of the interconnectivity across the nation and connecting the one nation, one grid. I think there is a fair amount of progress on that. See, the challenge in grid happens at the state level, at the lower voltages, whether it's a 33 kV or 66 kV or I think 33 and 11 is where the bigger challenges are. Right? I think those have to be done at the state level. I think that's something the losses, but these are all more DISCOM related challenges, and I think the path to that appears to be a PPP model. I think Orissa has gone and Tata has taken Orissa DISCOMs. I think Chandigarh is going, UP is going down that path, right? I think it's more than grid improvements, it's more administration of the DISCOM and eliminating losses. It seems to be the key driver or key area to focus on to improve the grid overall. And I believe a PPP model is what the government is driving. Of course, it's a state policy, not a federal policy, and each state has to make their own choices. But I believe that will reducing losses and efficiently operating the distribution system would automatically bring improvements. Right? But otherwise, the network is there, at least to my knowledge. I'm sure Mr. Nanda and Mr. Panda will have more to say, but I believe the network is not the challenge. It's the operation and maintenance of these networks that bigger challenge. And I think the PPP models are designed to address that, and they've been successful in Delhi and Mumbai, so and Surat. So I think more you will see.
Right. Before we close this session, I would like to ask each of our panelists, Mr. Arul, Mr. Nanda, and Mr. Furkoff, if anyone has any last final comments to make before we move on to our next session.
Nothing from my side.
All right. Mr. Nanda, Mr. Furkoff, any closing remarks or comments from you?
From my side, I think it's very exciting to hear of the, I think it happened maybe 2-3 years ago, so much excitement emerging in India to focus on hydrogen, that we maybe also from our Platts side should focus a little bit more in India. I mean, we see a lot of other pockets, like Australia, for instance, or the Middle East and Japan, but India is also moving, so many companies involved as well. I think the discussion is changing a little bit. I think maybe 2-3 years, I heard a lot of talk of using biomass, maybe to use that as a source for hydrogen, maybe produce it locally in all kinds of remote areas. But maybe the discussion has been changing a little bit. Maybe if somebody would have an opinion about that, it would be great. But it was just my observation of the past 2 years, maybe.
Thank you so much, Mr. Furkoff. Any closing remarks from you, Mr. Nanda, before we close the session?
One point which I would like to specify is, see, the energy storage technologies are going to play a bigger role in context of India for this hydrogen mission. Why I'm telling this is because the transmission or the grid or the transportation is the biggest bottleneck as on date. And the storage technologies play a very big role in optimization the use of the grid. I'll give you an example. Our integrated project, which we are talking about, is a 5 gigawatt project. But the transmission requirement for us is only 2 gigawatt for that matter. So if we are putting a lot of storage facilities in high concentration solar and wind areas, we can use optimally the existing grid structures for this transportation of excess RE available to us to other locations, and then eventually can be used for this green hydrogen mission itself. So I feel there is a need for encouragement of storage technologies, may it be pump storage, may it be other storage which are viable, which are cost effective, in line with the other enabling things which we are planning to do. That will play a huge role in the initial part of Indian context. That's what we feel.
Thank you. Thank you so much to all our panelists for an excellent panel discussion, and it was quite insightful and very interesting. So a very warm thank you to Mr. Nanda, Mr. Arul, and Mr. Furkoff for staying with us. And with this, we'll close this panel.